Thanks for joining. My name is Jason Bach, and I am a developer advocate at Rocket Mortgage. And I'm going to be talking about source generators, a feature that was added in C Sharp 9. So if you have any questions, again, put them in Twitter with the right hashtag. If anything comes up later, you can always email me at jason.r.bach@outlook.com or just send me a DM on Twitter. So this is an abridged version of a talk that I usually do that's much longer. So I'm not going to be going through all of the demos here, but just in case you want to take a look at all of them, you can go to any of these repositories here and check out the code. So I'm going to spend a little bit of time on the what and the why of source generators. Then I'm going to go through one of the demos and show you how to do object mapping with the source generator. And then I'll end with a call to action. All right, so first, the what and the why of source generators. Let's talk a little bit about what a source generator is. And to me, I think the best analogy, at least in my mind, that I could come up with that kind of talks about what a source generator is a factory. If you think about a factory and an assembly line, you have a lot of raw materials or maybe some prefabricated parts that are coming in. And then at various stages in the assembly line, you start putting together your product. And at the end, hopefully you have something that you can sell at the end, in this case, a car. And that's similar to what a source generator is, except we're not dealing with physical parts, we're dealing with code. So you can think of your source generator as a factory, and you're going to be looking at code that currently exists in your project and creating new code based on the state of that code. I should mention right now that when I say new code, I mean that you can create new code. You can't edit code that currently exists in your project, but hopefully that's not a deterrence to you, because even with just the ability to add new code, there are a lot of cool things that you can do with source generators. But you're not just limited to looking at code. A source generator is a class. And again, in the demo, I'll go into the details a little bit more, but you can look at a whole sorts of things. You can look at additional files within a project and examine them and create new code based on what you see there. You can, if you want, look at a database or a service, though you want to keep in mind that your source generator is going to run not just at compile time, but if you're within an IDE such as Visual Studio, it's going to run more than once. And so you want to be cognizant of that fact and make sure that your source generator can run as fast as it possibly can. So if you're reaching out to a bunch of services or things like that, that may slow down the experience, and you probably don't want to do that. But again, a source generator is just another piece of code, and that's what you use to generate your new code. So that's the what. Now the why. Why is this such at least in my mind, why is this such a cool, interesting, powerful feature? I've told people that I think source generators in C Sharp is probably one of the top 5 features that exists in C Sharp. Why do I think that? It's basically for 2 reasons. The first one has to do with performance. I think every developer out there has the intention of writing code that's fast and it delights their users and it makes them want to come back and ask for more features. But sometimes we use things or do things that don't always make the best experience. And again, this can come, depending on what libraries or APIs that we're using. One classic example is the reflection API, which is a very powerful API in the .NET world. It allows you to do introspection and invocation at runtime. It lets you do some really cool things. If you think of a testing frameworks usually have attributes you put in methods, and at runtime, that framework will look for those attributes and invoke those methods. But that comes at a cost, where it has to do all this work at runtime to look all this stuff up. Now, does that cost matter to you? It depends, right? It depends on the hot path of your application and your code and what it's doing. But reflection can add some kind of performance hit depending upon what you're doing. A source generator can allow you to essentially take a reflection path and hard code it such that it's compiled into your assembly at compile time and give you better performance. Another place where I think source generators help out a lot is ironically getting back to that analogy of an assembly line. That work that people do that's kind of rote, that's kind of repetitive, it's the same thing over and over again. It's stuff that we have to do as developers based on packages that we're using or frameworks that we're trying out, that we always have to do step A, B, and C or whatever they are. And it's not hard, it's not complicated, but we have to do these things. And we'd rather focus on things that are more interesting or look at problems that are ones that our customers really want us to solve. With a source generator, if you can figure out how to create that rote repetitive code, then that's one less thing that a developer has to do and you can save some time. So let me give you a couple of quick examples to illustrate this. If you've ever had to implement iNotify property change, you probably know what I'm getting at when we talk about repetitive implementation. iNotify property change is a standard interface that you can use to let consumers know that the state of your object has changed. And if you look at this code here, this is a typical implementation of this interface. On the property setter, you have to check if the state has changed, and if it has, then you essentially raise the event. This isn't hard. This is fairly easy to do, but it's also something that just takes time that we'd rather focus on something else. And from my understanding, this is one of the main cases that source generators was designed to solve. And if you look at the last slide in my slide deck in the notes section, there's a whole bunch of references to things. One of them being the cookbook that came from the Microsoft team for source generators. And they show a way to basically take this and turn it into this. So now what I can do is define my class as a partial class. And the reason why is because a source generator is going to look to see, do you have fields with this auto notify attribute on it? And if you do, what it's going to do is create another partial class implementing iNotify property change and do all that work I just showed you on the previous slide. So this is much easier for you to do, and it does exactly the same thing that you would have done if you wrote it by hand. From the reflection performance standpoint, if you've ever wanted to do object mapping, one way that you could do it is just do it through reflection. This is some code that I just wrote one day and said, if I had to write an object mapper with reflection, what would I do? And so you don't have to read this code in detail, but basically I'm looking at objects, looking at their properties, which ones match to which, and then setting the values on the destination. So I can have a method that does this generically, but again, this is using reflection. If I wanted to do this for a specific source and destination type, I may do something like this. And this is about the fastest that you're going to be able to do it. Keep this in mind because this is the source generator that I'm going to show in a moment in my demo. And this again gets rid of that reflection path and gets everything to be compiled at compile time. You can also debug it as well. So I'll demo all this in just a moment. Now, one thing with source generators that you need to keep in mind is if you're new to them, there is a little bit of study. There is a little bit of investment into understanding the compiler API because that is the backbone of everything in source generators. You're going to be using syntax trees. You're going to be using semantic models. So it may take a little bit of time to get up to speed. It's nothing that is impossible to do, but there is going to be an investment. But I think that investment is worth it. And that's where that profit aspect comes into play because you're now going to be able to potentially reduce places in your application where your performance may not be the greatest and make it better, but you're also going to save time for developers in eliminating those rote repetitive tasks so they can go work on other things. So hopefully with all those combinations in place, you can start to profit from a source generator. So let me go into a demo right now and show you the essentials of a source generator and how they work. Okay. So I'm going to come over here and let me make sure that I've got my code up here and we are good. Okay. So this demo actually has 3 source generators in it. Because of time, I'm not going to be able to go through all 3. You can take a look at the other ones later if you'd like. The one I'm going to focus on here is showing you an object mapper that I have created called inline mapping. Okay. So how does this work? I have a source class here that has 3 properties that I set when I create it. I'm going to print those out to the console window. And then I'm going to have this map to destination extension method that's going to create me a destination object. You've already seen essentially what this extension method is going to look like. I'm not going to show it right now. I'm going to go into the actual library, show you how it's generated, and then we'll come back to this. I'll print out that destination object, and you'll notice that at the end, we also have a fourth property, reason. So if I run this, what you'll see is right at the end is there's a comma with nothing after it because reason couldn't be mapped to anything. But the other values are exactly what we saw from the source object. Okay. So how does this work with inline mapping? I'm going to go over to this version of Visual Studio here. First thing I want to show is when you create, if you want to create a source generator, is that you'll create a project. There's a lot of properties in here. The things I want you to focus on first is the target framework. Make sure that you're targeting .NET Standard 2.0. You also want to bring in a couple packages that give you all of the compiler API goodness. Okay, so if you have those in place, that's the good starting point. The next thing you want to do is actually create the generator class. So as I showed before, you'll have a generator attribute on your class, and you'll implement, if you're in the .NET 5.0 way of doing it, iSource generator. There is actually in .NET 6 a version 2 of source generators where it's called incremental generation. And I haven't updated my stuff just yet. That's on my to-do list. But I do want to share a link here with an article that, bring that in. This is from Andrew Locke, who just published it this week, talking about incremental generators and how it works. So I'd highly recommend hopping over to his site. And if if this whole conversation about source generators appeals to you, then you may want to take a look at this, especially if you're jumping right into .NET 6, so you can see how this next version of generators works. But the essential machinery of what I'm going to show you is more or less the same thing. Okay. All right. So we've got the core things in place. Now we need to implement this interface. The main method is execute. Okay. And I'll hop back to this in just a moment. The other method is initialize. And what I have been using initialize for is essentially a filter. Remember, the compiler is going to be telling you all sorts of things about your code. In fact, if I use a tool called the Syntax Visualizer, which you can get if you install the .NET Compiler SDK for Visual Studio, if you go to sharplab.io, it also has a visualizer for you as well. But if I bring that up and click on my code, you can see I've got a whole tree here that represents everything in that source file. But I don't care about everything. I only care about a couple of things in my code. So what I want to do with this initialize is to register for syntax notifications. And I can create a receiver that looks like this. It implements iSyntax context receiver. And then there's one method called onVisitSyntaxNode. So you can imagine the compiler infrastructure just giving you all this information about all the syntax nodes that it's seeing. And I can use that to say, I only want to look for a couple of things. In my case, I may want to look for a type declaration because I want to see if I go back to my code over here in source generator demos, go look at the source here, you'll see that I have a map to attribute on that source class. And I'm saying map to destination. I also support map from and map. They all eventually lead down to the same path. Okay. So in this case, I'm looking for type declarations because if I get that node, then I'm going to get its symbol. That's the semantic model. So, syntax tree and syntax nodes are basically the syntax of your code. Semantic models give you more information that's a little bit easier to digest and use from a syntax model or a syntax tree. So I get the type symbol, and then from that type symbol, I'm going to look through all their attributes. And if I find an attribute that is the same as my map to attribute, which I loaded here above, then I know you're saying I want to do a mapping. And what I do here at this targets is I'm essentially pulling out the source and destination type so I can do some processing with it later. Okay. Now, if I go back to my generator in the execute method, I'm going to look at the receiver and see if it's of the type I want. And if it is, then I'm actually going to generate some code. I'll go back to that in just a moment. This is all up to you at this point. Whatever you do to generate the code, you can just use string concatenation. You can use a string builder. I use an indented text writer from the CodeDOM API. You can use Scribin, which is a templating engine that's out there for .NET. Doesn't matter as long as what you come back with is what's called a source text object, which is a wrapper around a string. And that string contains your new C sharp code. And that's what you pass in to add source here. Add source takes the name of the file or the new name of the source, and then also this text, which is a source text type. You can also report diagnostics if you find things that your source generator can't handle or do things with. So you can let the user know, hey, something's wrong. And based on its severity, that might actually stop the compilation process, which is maybe what you're looking for. Okay. Now, to actually generate this code, as you can imagine, there's a fair amount to it. I'm only going to highlight the essentials. The first thing I'm going to do is call mapping information. This is a type that I use to go through all of the results I found from the receiver and determine if there are any issues. For example, if I can't find an accessible constructor on the destination type, I'm going to flag that as a diagnostic because then I can't actually create that in the code that I'm going to be generating. Or maybe I can't find any properties that map between the two types. I'll also create a diagnostic for that. So based on what I find, either I'm going to have diagnostics or be able to actually do a mapping. And that's what I use this mapping builder class that I'm going to create here. So in this mapping builder, this is where you're going to start to see where I use indented text writer. The reason I use this is because then I can indent code in and out. And me as an author of a source generator, it makes it a little bit easier for me to look at when I'm maybe putting in a new feature and maybe I mess something up. I can look at the C# code and easily see what I did wrong. It also, I think, is easier on the eyes for people if they want to actually look at the source generated code, which you can do if you're consuming it. I'll show that in just a moment. So I'm starting to build my code with this writer. You can start to see here's some like a namespace in here within some C# code. And I'm just going to keep adding this to the indented text writer. I'm going to start building that actual type that's going to hold my extension method. So here you can see I'm going to build a static partial class with those extension methods in there. And those extension methods are built in my build map extension method. Because I have so much flexibility with the source generator, I can detect if the target type needs a constructor with parameters. So when I generate the actual static extension method, I can also have it pass in parameters so the caller can pass in the values that need to go into the constructor. And then I will in turn pass those into the new destination object. I can also check to see if that source is a reference type. And if it is, I'll put a null check in there. I'll also come down to here, which is where we actually do all the mapping. And as you can see, it's pretty simple. I grabbed all the names of the properties I know I can map. And so I'm basically going to say here that I'm going to have a new destination object. And then I'm just going to say x is equal to the source.x. Okay. So what comes out again at the end, if I go back to my demo and come up here, when I go into that extension method, you'll see I have all that code generated already. And if you look in Solution Explorer, you can see when you have taken a dependency on a package that does source generation, you can go through this tree here and you'll see all of the files that it's generated. Now you can't change these either, but what you can do is, for example, put a breakpoint in that code. So if I hit F5 here, you'll see that I actually stopped on that line of code. And in the locals window, I can see all the values here and introspect and look at what's going on within this code. This is very nice, pleasant experience to see what's actually going on with source generation. Okay. I'm going to pull this over here because what I want to also show is, let's say I take this property and put it into the source. You'll notice that after a certain period of time, that reason property mapping showed up. And if I take it away, it goes away. So again, this is the Visual Studio infrastructure kicking in at a certain point saying, hey, you need to run your source generator again. And when we do, we see those updates. Now, one other thing with the source generator is I wanted to look at its performance. So in my inline mapping repository, I created a project, a performance tests, that I created some benchmark.net based tests to see how this compares my inline mapping approach with the reflection approach that I showed you in my slide. And then also some packages that currently exist like AutoMapper, Mapster, Mapping Generator, and so on. you've ever used benchmark.net, you know it takes some time to run. So I grabbed the results from a run I did on my machine. And what I get is, especially if you especially look at the reflection approach compared to my inline mapping, the source generator approach is 3 orders of magnitude faster, and it also has 2 orders of magnitude less memory consumption. AutoMapper, which is a very popular library to do object mapping, has a lot of optimizations already built in, but it's still just a little bit slower and consumes just a little bit more memory. I don't think AutoMapper's actually been updated to use source generators just yet. If it hasn't, that may be something it can use to then get some more performance. Mapping Generator is a library that actually generates essentially the same code that you see my inline mapper mapping project do, but the way it works from the NuGet package is it requires you to manually invoke it through as a refactoring. Okay. But again, that shows you when you can generate that code that you can get really good performance with minimal memory allocation. All right, so that is my demo. Let me come back over here and get this running. So, what's the call to action? What is something that I want you to take away from this presentation? If you've never used source generators before, you might have used a library that was doing it, you just didn't know it. But maybe this has started to make you interested about you creating some yourself. And that's the thing I want you to do. I want you to think about your code and places in your code that maybe a source generator makes sense. Maybe you've got a hot path in your code that if you could do some source generation, that may make the performance better. Maybe there's something that you know your developers have to do all the time. Whereas if you package that up as a source generator, that takes that work away from them and they can focus on more interesting things. The .NET community has already done a lot of things with source generators. This is just a small list of many projects that I've seen out there. .NET, Microsoft itself has actually done some things with source generators now in .NET 6. There is the JSON system text JSON library that is now using source generators to handle serialization. And I've heard that they're looking at using source generators for regular expressions in a future version of .NET. So you're already seeing the team itself using source generators to make things faster and make things easier. So hopefully you can think of some things in your own code that you can change into a source generator. So that's all I've got. Hopefully this has been interesting. I don't know if there's going to be any questions or not. Maybe we'll see. But if something comes up later, again, just send me an email or hit me up on Twitter with a DM and I'd be happy to answer it there. So again, I'm all done with my presentation and I want to say thank you all for attending.
Great job, Jason. That was awesome. We do actually have a few questions for you.
Okay, well, I got time.
Great. So Ben wants to know, how do C# source generators compare to F# type providers?
I have no idea. I am not an F# developer, and I know that will probably bring in a lot of, you should really look at F#. From all I've heard about F#, it's a great language, and I have nothing against it. I'm just not fluent in F#, so I really unfortunately cannot answer that question.
Understandable. We have another one here for you. Is there always going to be a dependency on net standard for source generators, or is it planned to be able to have them on .NET 6 without it?
Yeah, so this is something that doesn't just affect source generator projects. If you've ever created like an analyzer project, the same thing applies that you're going to target .NET Standard 2.0. This is something that I actually asked on the Discord channel for .NET. There's a .NET channel out there, and a lot of Microsoft folks hang out on various channels there. And I asked, is this restriction always going to be in place? Part of the reason that this is here is because Visual Studio itself is targeting .NET Framework. It's not targeting .NET Core. And can't load more than one without a lot of gyrations, essentially. So if you target .NET Standard, then you don't have to worry about what underlying runtime is actually going to be used by the compiler. It's my understanding that at some point in the future that this will switch over to .NET 5 or 6 or whatever version that would be. When that happens, I don't know. And I don't know if the team actually knows either. That'd be a question for them. But I know it's a goal to eventually hit at some point. But for now, if you target .NET Standard 2.0, then even if you're only targeting like .NET 5 or .NET 6 type of applications, you'll still be able to run in whatever, if you're just using .NET Run or Visual Studio or Writer or anything like that.
Gotcha. Maybe the team can follow up on Twitter there.
Yeah.
Okay, so in which other tasks can I use the generators different from mappings?
So if I understand that question right, can I use the generators different from mappings? So if I understand what Julio is saying, basically, can I do other things with source generators? I don't want to, I think that's what the question is asking. I don't want to assume, but if that's what the intention is, then yeah, you can do a whole bunch of other things with source generators. That's what I was showing on one of the last slides is there's a project out there called Strong Inject, and that was written by somebody who set up a whole infrastructure around an IOC container that everything can be checked at compile time. So you don't have problems where you forget to register something in your container. If you do that, when you use Strong Inject, you'll actually get a compile time error, which is really, really cool. And there's a whole bunch of other scenarios out there as well. Again, the last slide in my slide deck in the notes section, I have references to a whole bunch of things so you can check out what other people have done with source generators.
Amazing. And as we mentioned, it will be Javier's job over the weekend to upload all of those slide decks to be publicly available in the repo. So
and actually, I do get a question though here, Jason. It's like, what have you used the generators for that it would be kind of like, oh, this is a great way of simplifying the task. You were talking about, the DI concept, but I can see it as like, I need to bootstrap middleware and an ASP.NET core application, right?
Mm-hmm. That's a possibility. I mean, that might, if you have like a standard way of doing that, maybe you could write a source generator to just create all that for you. The other two generators I have in my demo, which if I was doing like a full 60 or 75-minute presentation, I also have a package that lets you do partial function application. So if you know what that is in software development, that basically allows me to create a new method where I've essentially hard-coded a couple of the parameters, and I use a source generator to do that. I also have a mocking framework called Rocks that is all source generator based. And one of the really cool things about that is because you're generating code, you can essentially generate a whole API shape that, at least in my opinion, makes things a little bit easier when you're trying to set up a mock object. So, there's lots of cases out there, and it's just how imaginative do you want to be in thinking, well, if I'm always doing this, if I made a source generator, can I just let that handle doing that? And then if I do that, well, then because I'm generating code, what else can I generate to make my life easier as a software developer? So I think there's a lot of applications for this.
No, that's really great. Again, Jason, thank you so much for answering the questions. And as I mentioned to others, the questions are typically lagging 10 to 15 minutes behind because depending on people are on the stream. So go check out Twitter with the hashtag .NETConf to see what other questions other people may have.
All right, I will do
Great.
that.
And thank you so much for taking the time to donate your passion and your time to .NETConf. I really appreciate it. And it's good to see you, even though we live 3 hours away. This is typically the only way we get to see each other.
Exactly. Well, thank you for having me. I appreciate it.
No worries. Thank you. I'm going to bring Jeremy Sinclair on board so we can kind of get started a little bit earlier. So I'm going to,
Thanks, Jason.
thank you, Jason. I'm going to remove you from the stream.